stuff we can do with it. Okay, so yesterday's movie, and right off the bat, good, Frozen. So I get to mess with the program that's very finicky. Um, and you guys, I didn't get to say this first hour, but I said it in the video when I made it fourth. Draw that this chapter is like cut into two different parts. One is the what I call the Sir Kixer Tix, and then usage of later identities to evaluate trig functions using some identities, and you end up with a number as an answer. And then the other part is just using the identities like in doing a geometric proof kind of thing where your work matters and what you do is end up simplifying expressions and there are no numbers. The final answer, well, it could be a number. That's a mistake. But you simplify the situation. Like for instance, who knows what this is equal to? Let me finish. So you have this as an expression. What is that equal to? 1. So the very next step, you could say, oh, I can simplify this, and that is equal to the number 1, and then that's the final answer. That's like the other part of this chapter. That's the problem solving. No, I think what I said with you guys, dang it, puzzle, like solving a puzzle. All right, and all it is flat out substitution. And that's what you're trying to find. You're trying to find simpler ways of writing an expression. So it's going to toggle back and forth between this. Actually, yesterday, your homework toggled back and forth between Sir Kix or Tix, but then also identity questions, and then using those identities. So I did say that yesterday in the Period 4 movie. All right. And then I did warn you that this is going to be your quiz. You have to fill in the blanks. How could we complain about that? You have the dang quiz right in front of you, and it's going to be probably tomorrow. All right? So we got to get these memorized, especially this 5-1 section, so that we can use them very fast the rest of the chapter, not have to keep looking them up. All right? Very important. Then I left these blackened out. Okay, so you fill in that, that, and that. And then these Pythagorean identities, which is the ones that really end up students messing up, I guess, is the best way to say it. X squared plus y squared equals r squared. We should be able to do this fast now. When I divide both sides by r squared, first of all, what's r squared divided by r squared? 1. What trig function is x over r? What trig function is x over r? Cosine. What trig function is y over r? Sine. So squared, of course, that's the first one by dividing by r squared. This is your escape. This is your who goes with what, and so on and so on and so forth. And then those that do really poor in Chapter 5, I think still don't know Sir Kix or Tix from Chapter 2 and 3. They don't know sine of a 30 is a half real fast. They can't find cosine of a 60 real fast. But going back to what I said there, Sir Kix or Tix, when I divide by x squared, the only reason you get this wrong is if you still don't know who is who. What's x squared over x squared? 1. What's y over x? Which trig function is that? Tangent. Those that don't know that, that's when you go down. All right, what's r over x? Secant. So I don't know which one this is. Yes. Woo. All right. I didn't want to reveal the wrong one. Boom. And then, of course, I didn't divide the other side by that, but or I think I just erased it. Last one is divide by y squared. What's x over y? Cotan. What's r over y? What's r over y? Cosecant. And there's that last one. So there should be no reason why we can't fill out the 3 different Pythagorean identities. Off to the right is your... You don't have to write this for work. This is your how I can find it, and I can derive them real quick if I forget who goes with who. And I just try to please remember that cosine, it doesn't matter with that negative stuff. Cosine of negative theta equals cosine of theta. And then all the other ones, it does. And then that might be a way to remember these, what's called even-odd identities. You have to get these memorized. The quicker you do, the quicker things are going to go for you here as far as positive stuff. All right. The book does give some simplifying hits. hints. I don't know if you want to write these down or not. I like some of them. Some of them are a little, I don't know. They're not wrong. I think sometimes we get robotic and think we should only do certain things. I do want to mention this though. Um, Number two happens a lot. Um, you know, the trig identity for sine. I know I'm jumping around here, but I just kind of squirrel kind of thing. I looked at it here. Sine squared plus cosine squared equals 1. Does that mean sine plus cosine equals 1? That's like saying 3 squared plus 4 squared equals 5 squared. So that must mean 3 plus 4 equals 5. Does 3 plus 4 equal 5? No, these have to be squared in order to make these, that substitution kind of stuff that I mentioned up there. All right. Now, I will say this. Number one, when we're simplifying, which is what the next part is, like I just kind of intimated in the notes up there, sine squared plus cosine squared. 1. And then I'm done. It's really simple now. Um, One of the best things to do is write everything in terms of sine and cosine, because then you can start getting some fractional cross-canceling. And we'll see that quite a bit. If you see squared trig, that's why I put this right here. You may have step 1, but it might also be a Pythagorean identity that you could substitute some stuff in. And this is why you have to have the stuff memorized. So that when you can see it and it's memorized in your head, you could say, oh, sine squared plus cosine squared is 1. So I can write 1 in its place, a substitution. All right, but anyway, if there's trig squared, it might be a Pythagorean identity substitution. And that's why you need to have those memorized. You may have to do some algebra, like distributing or foiling. Yep, that's going to happen. And then fractions become a big problem. This is why I've been a fraction jerk since August. Your fraction calculator button will no longer help you. If you've been using that to try to get by with fractions, then you've circumvented the system of when I add fractions, what do I need to get, everybody? Common denominator. When I multiply fractions, I can cross, not multiply, cross cancel. When I divide fractions, what do I do with the second one? Flip, and then I can maybe cross cancel and multiply. All these basic skills. This is a weird one. This happens a lot. Over here, if I have, this is the opposite of the common denominator rule. We have to do this quite a bit sometimes when we're simplifying expressions. Instead of having them underneath a common denominator, split them up into, two different fractions, splitting up the common denominator. That's just like this. I don't know why we would do this, but I don't know. Just, what you would do with 3/4 plus 1/4, right? You'd make that 3 plus 1 all over 4, and then, of course, that's 4 over 4. But this is just the reverse of that. Just look at this way. It's legal. If I have something over one common denominator, I can't split it up into two fractions. I know in the red one you wouldn't do that. That would not do anything. But I'm just saying that it's legal to do that. And in trig, sometimes this is a rare but needed operation to do. All right, so it shouldn't cause stress about that. But what is difficult about this is imagining, what do I have to do in order to get this in simple form? Many of them are flat out easy, but some do become a challenge. And that's where the chapter becomes a challenge. I'll pause for a second. I should have said that online, which I will. What's frustrating about these identities is sometimes you do something that's perfectly valid, but it just doesn't simplify, and you got to try something new. So only the students that have good efforts and are willing to pick themselves up and try again will do well on that kind of stuff. All right, I just lost myself here. There we go. Okay, now this is right out of the book, and I like this little. Didn't you have one like this yesterday? This isn't the one from yesterday, right? The one from yesterday was a lot more basic. And with a matching, you often are given the latitude that once I get one answer, then I'm done. That answer's done, and I can move on. All right, and this is going to get kind of messy, but I'm going to take these one at a time. And I said for 38, you want to try, because look at this is cosine. So this is already cosine. Is there a way of putting this in terms of sine and cosine? Right? I know it's 1 over cotangent, but does that do anything? Do I see cotangent anywhere else? Yes or no? No, and this is the idea of what we do. Most of the times it's turning everything in terms of sine and cosine. And tangent is the same as sine of x over cosine of x. And that's something that you should have memorized by tomorrow. You should have it memorized by today. It wasn't the first time that you saw that. Times, and this is what I mean about knowing how fractions work. Cosine of x is cosine of x over 1. So now what happens? What happens fractionally? What can I do across multiplication? You tricked me. It's cross cancel. It's not cross multiplying when you do that. Cross multiplication is how you solve equations with fractions. All right, do you see the answer to the right, yes or no? Well, which one is it? It's not exactly the one that I'm looking at there. It's C, because negative sine of x does equal sine negative x. That is that even odd identity. So this one is C, and guess what? I'm done with that one. Okay? So again, I use two identities there, changing tan to sine over cosine, and then the even odd identity is, I guess, what they call that there. Hey, go look at 39 here. Actually, we can do something about this. And actually, it'll work out probably. And again, sometimes you try something and it doesn't quite work out, but we'll see. So secant squared minus 1. Interesting. Do you know anything about what secant squared is? Remember what I said about trig that's squared? We should look at a trig Pythagorean identity. What does secant squared equal to? What does secant squared equal to? 1 plus tan squared. This is what I mean about substitution. I'm going to put this in parentheses and color it yellow. This is what I mean about substitution. If secant squared equals 1 plus tangent squared, I can plug it in then. There's another way you could have looked at this, but I think this is the best. What happens with the ones? What happens with the ones? They cancel, and then you're left with a lonely tangent squared. Which letter represents tangent squared off to the right, I guess, but now it's to the left. It is A, and this is a good point, and I notice students mess this up sometimes. Yes, tangent squared is equal to, this is the way we can look at it. Tangent squared is tan of x squared, which is sine of x over cosine of x squared. And then, yes, you would distribute the squaring into both functions. Okay, so yes, both of them are squared when you write tangent squared as a fraction. Okay? All right, let's press pause for a second, make sure everyone's okay. All right, and the beauty of usually with matching is they kind of disappear as we use them. Next one, here's fraction world. Oh boy, fractions. You know what I'm going to do right away? I don't know how these mesh secant and cosecant, so I'm going to go ahead and change them to, what's secant? What's secant? 1 over who? Cosine? Now this one doesn't really simplify. I guess it does a little bit. And then what's cosecant? What's cosecant? 1 over sine. Here we go. This is going to happen so much to you. So much that you have like fractions within fractions and you got to be able to deal with them. Hey, what is this operation right here? What's this operation right here? What is that? Division. So what does that mean? Is this the back button? Yes. What does that mean this is? It's 1 over cosine divided by 1 over sine, written in the classic, grade school division way, I guess. What does dividing by sine mean? I'm sorry, dividing by 1 over sine. What does that mean? What's going to happen? It means multiply by sine. And then what does this become? What's sine over cosine? Tan. Okay, now we're being a little, since it's a matching, we're kind of shorting our work a little bit. I could see that that would end up being, and then knowing that sine goes above cosine when you multiply those fractions. You multiply the numerators, multiply the denominators. Okay, fractions. Ooh, we got some weird ones. Okay, now your classic multiple choice matching students. Where do you think you would go next? Would you do 41 or would you look at 42? Look at 42. What's 42? B. Come on, that one's easy. That is the flat out definition of 1 over. Again, cosine squared is 1 over secant squared. The powers carry over. But I'm not going to shortchange you on this one. This is so weird. This is so weird. Look at your Pythagorean identities. Look at your Pythagorean identities. You could go right there, right to it. What is 1 equal to? Take a wild guess. Look at the difference between 41 and D. What is 1 equal to? And I can prove this. What is 1 equal to? Not cosine. What is 1 equal to? Just read that. Cosine squared or cosecant squared minus cotangent squared. Go take a look at it. This is one of the weird ones. Don't get stressed about it. If I subtract cotangent squared of theta, is this the one that I wrote in the notes yesterday? I think it might have been. I said, hey guys, what do you think that's equal to? And you guys said 1. Isn't that wild? Okay, so that's one that different forms of these. That's where it gets a little bit tricky. Those that really do well with this in the memorization can move around different forms of the Pythagorean identities then and understand those. So yeah, that is equal to 1, so that is why this is true. That is the opposite of simplifying, by the way. So sometimes in these matching questions, they get real tricky with you. All right. Most of the times, this chapter, you're going to be simplifying and reducing these expressions, just like what I'm going to show you coming up here. All right. All right. Okay, rock and roll. I used to call on students. I guess I don't anymore. Don't want anyone hugging the bear because of anxiety. Getting called out on class. I used to call the names out all the time. Boom, 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 boom. All right. What's cosecant of theta? See, now look at this. I think you could see, even though this is in the beginning stages of this, I have a bunch of multiplication all the way across. I have a cosine in the middle. I think the most natural thing is to write everything in terms of sine and cosine. And I heard you. It's 1 over sine. What I'm doing is getting these in, you got to think variables. I'm trying to get like variables. And the most common like variable is in terms of sine and cosine because everything can be written in terms of sine and cosine very easily. Cosine's just cosine. Keep track of your fractions. Over 1. I like doing that. And then what's tangent? Because I do have people mess this up, what tangent is. Sine over cosine. Remember, tangent is ticks. Just try to remember tangent is ticks. And sine deals with y. Cosine deals with x. Right? Sine is y over r, cosine is x over r. So ticks, sine deals with y, cosine deals with x. There should never be a problem. Then cotangent's just the flip. Don't even try to think of that one. Just flip it. All right? And then that's the best way. Hey, what's the answer? This is crazy. 1. After all of that, all of this stuff is... You can't argue that is not simplified. That was a double negative. I don't care. Right? Did I say it right then? You can't argue that that's not simplified. I don't know. Let's move on. Oh no! Here's this classic. What do you think I do with this? First of all, this is what I get people do all the time. I'll show it, and I'm going to show you this just because people get in these little loops of doing stuff, and then, well, I know secant's 1 over cosine. And then I know tangent is 1 over cotangent. Does that do anything as far as simplifying, yes or no? You're not getting a common language. You're not getting any common variables of what things might be when they cancel, I guess. So 1 is good though. It's about all I can do with secant. There's not much more. What am I going to do about tan? What is that? Now, this is my good fraction, people. Oh boy, I lost my pen. Okay. Oh, thank you. Um, who cancels? My good fraction people. The cosines cancel. All right, it's the whole division thing of what goes on. I guess we could write it. It's 1 over cosine divided by sine over cosine. That's what this means. This is having to write it all the way out, though. This is 1 over cosine times the flip. But I wanted you to understand, those that do this fast, that this ends up leaving sine on the bottom. So when I cancel this, that is 1 over sine. Okay, and sine is in the denominator. By the way, what is 1 over sine? Okay, so you can either, sometimes it says write it in terms of sine or cosine. But if you went ahead and did this, both would be the simplified answer, one or the other. Read your directions. Sometimes it says write the answers in terms of sine and cosine. Okay, 1 over sine. All right. All right, Mickey Mouse Beginnings here. Probably got a very similar situation with this one. Again, cotangent's 1 over tan. That does nothing for cosecant. Nothing at all. So when you put true statements down, well, I did something. Well, you didn't really do the best thing, I guess is what I could say. What's cotan? If tan is sine over cosine, cotan is cosine over sine. Memorization. And actually, through doing appropriate homework, the memorization should happen. All right? There should be no reasons why we're not getting this 5-1 page really memorized well. I don't know if my English is going very good in first hour today. What's cosecant of theta? 1 over what? Sine. What's this final answer? It's just cosine. These cancel, and you have cosine divided by 1, divided by 1. I don't know. It's not really. It's just cosine. You get it. All right? And then that's certainly simplified compared to what you saw before. You had 2 functions of trig, and now you only have 1. And then I will tell you, I'll be honest, what's the point of these questions? Wax on, anyone? Wax off. To get used to this process, to help you memorize that page if you do your homework appropriately, because your world is going to expand on this. So it really is the case. Oh, no. It starts with an F. Fractions. The wrestler over there looks like he's actually in a boxing match. Poof, poof. The math is just about to knock him out. His head's wavering all over the place. You all right over there? All righty then. Still, you're going to want to try the sine cosine thing. Let me think about this. Sometimes we do something and it doesn't. Oh, yeah, we're good to go. See, here's what I did. I just had a little electricity go in my brain. I did a couple steps in my head. I changed cosecant to 1 over sine. What's going to happen with sine divided by 1 over sine? It's either going to be 1 or sine times sine. Which one is it? It's sine times sine. Here's where you're going to get in trouble, though. And this is the non-working people, and if you argue with me, you are going to lose. You are going to write your stuff, because when this gets into proving identities, it's a geometric proof. Your work is the validity of your mind and what you think is going on there. Because remember, there's a bunch of copiers in this world. And by the way, when we get to identities, you're going to have the answer. The answer is going to be right in front of you. Just like a geometric proof. They tell you what the proof is. They tell you what you're supposed to prove. That is true. It is your logic that gets to there, and that's where this gets to be a problem. The students that don't want to show work and want to argue about it. So you will write this, or you will not do well in this chapter. And I got to be that way because we got to nip it in the bud early. Got to nip it in the bud early that what your responsibility is. So get used to showing all the steps. Now I am okay with this next one. We should know that dividing by 1 over is the same thing as multiplying by sine. Okay, so we should know from writing that step that this is sine squared. If you need to write that out and show divided by 1 over sine, multiply by sine over 1, that's on you. So there are give and takes on this. But this is imperative that I see this, and then there are some gray areas where we can go from there. Okay, but I need to see that initial step, and then we can go from there. By the way, what's the final answer? 1. This simplifies to 1, and understand what we're doing. We're simplifying. All of that equals 1? Yes, it does. Is that a hand? It is a hand. Okay. Alrighty then. You got a couple things you can do with this. What might someone try to do right away? The algebra person, the algebra, and you might want to what? Distribute. It would be a mistake in this question, though. Because, what did I tell you about trig squared? What should we search for? What should we search for? Trig, which identity? Starts with a P. Pythagorean. Does anyone know what that is without looking? See, the more you can not look and then guess it, then look is better, huh? Cosecant what? No, it's just cosecant squared of theta. That is a flat out what it is, and I'll zoom up to it real fast. I can get there quick, sort of. Okay, where is it at? Okay, all right, right there. Oh, I want to erase that. There it is. This equals that, so I can substitute that. All right. Oh, and I just thought of something. You don't trig air. You will always have the theta there, the cracked egg. The lazies don't put the angle there, and they just start trying to shortchange me and so on and so forth, and it ain't gonna work, man. Just trying to give you some ideas as we proceed forward. The precision that we're going to ask for. No laziness. And I guess I'm okay with this. Does anyone know what sine times cosecant? We actually had this written in chapter 3. What do you think sine times cosecant should be? Sine times cosecant, what should that be? Oh no. What's cosine times secant? Might as well go over this right now. And then what's tan times cotan? These are all starts with an R. R-E. R-E-C. Reciprocals. All of these should equal what? 1, 1, and 1. Okay, fine. I'll prove it. Sine of theta times 1 over sine squared of theta. Who cross cancels? One of the signs. Boom and boom. You're going to want to do that way. Did you notice how I got rid of the squared and now it's just sine? And then what's the final answer? It's either 1 over sine, or we turn back and call that cosecant. Probably depends on your directions. Both would be right. If it's a multiple choice, only one of those will be listed. You got to be ready for either one of them. All right. So it's different ways of answering depending on the directions. This is where this gets weird. It gets strange. So you see a sum, you see one fraction, you see another one that's not. So I think someone could already see what's going to happen here. What am I going to do with the sign? Do what? No cross-canceling. Thank you. All right, this is a big problem in this section. You cannot cross-cancel across plus. So I'm not picking on that student. That is one of the biggest things that happen that cause destruction of these. What can you only cross-cancel across what operation? Multiplication only. Boy, I'm glad you did that, because that is a very common error. Hey, when you add fractions, you want to get a what? Common denominator. So ask yourself those common questions. How do I get a common denominator? What is it? Sine. So what do I have to multiply this one top and bottom by? Sine. This is back into August, how to get a common denominator with, quote, variables. And that's what we have to treat the trig functions as, variables. Are you okay over there? Taking a little siesta? All right. What's sine times sine? Sine squared. I'm going to put this over here. Then we're going to have hard, fast rules when we get into the identities section. These are not identities. These are just simplify. And then see what you can do. Hey! What's sine squared plus cosine squared? 1. What's 1 over sine? Yet again. That seems like our popular answer today for no apparent reason. You got to admit at least it's simplified. It's smaller. That's just one answer. I'm just saying what should the answer be in? What? Last one. And then maybe for the video I'll go back to that one that I skipped. Oh, please. What should I do? Right away when I see squareds. I want to simplify. Usually simplifying means you get rid of the plus signs if you can and turns it into only multiplications. So I see the squareds. What should I do? Should I change that one using... Oh, jeez. Should I change this one using a Pythagorean identity? Nah, it's just cosecant squared. The top one has a plus in it. It's actually more simple to get rid of those plus signs. What is 1 plus tangent squared? Secant squared. Now I'm going to blow your mind. You ready for this? Are you ready for this? Boom, 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 boom. Secant squared of theta over cosecant squared of theta. I hope you can handle this. Cosecant squared on the bottom can be turned into blank on the top. Anyone? Sine squared because they are reciprocals. And then secant squared on the top can be turned into what on the bottom? Cosine squared. These are the things that when I'm looking at your logic for steps, I'd love to just see that. I would rather not see 1 over cosine squared, 1 over sine squared, change division to multiplication and flip, and then come down to that. We do want some efficiency. We do want to have these ideas in place in our head, what it means to be a reciprocal and how we can flip things like that. That is 100% true. What I just wrote there has exercised the reciprocal rule. No questions asked. Hey, what's sine squared over cosine squared, everybody? And it does turn into tan. Say it. Tan squared of theta. What we're not going to make you right is this. Sine squared of theta does mean, over cosine squared of theta, does mean this schematically. So that means I can change that to this, and then it just, trig people would rather you write the squared here instead. So you don't have to write any of that, but I'm just saying this is why sine squared over cosine squared equals tangent squared. And we can just go right to it. All right? Just to finish the video, I'll do that one that I skipped. Ooh! Now, I'm going to go off what was said before that people will illegally do on this. And it is illegal in math to do this. You should be arrested by the police cops. Wait, the police cops? The math police. Sorry, that came out wrong. Can I cross-cancel across plus? Yes or no? But I will get people that do that. And then they'll end up saying like 1 plus 1 equals 2. Heck no. So we're at an impasse. Fractions are the worst. So what do you think you're going to do? Get a common denominator. We can try it. What do I have to multiply this bottom one by? This left one by. What do I have to multiply top and bottom by? Sine everywhere, sine. What do I have to multiply the right one by? Cosine. This one still ends up being a little strange. But at least something happens. And sometimes what you get for a final answer doesn't look simpler than what you started with. So that can be a problem. And that's why you're going to like identities better when you have the actual answer. It really tells you where you have to go. But at least you see something happen here. And you should do this. What's the point of getting a common denominator? To put them all underneath that common denominator. We shouldn't have to write this as two separate fractions anymore. That's the point of getting a common denominator. That one that I had there, 3/4 plus 1/4 equals 4 over the common 4. Okay? And what we have up in the top is sine squared plus cosine squared. Yet again, what is that? That is 1. Now this is where you can argue, did this get simpler? 1 over sine times cosine. And you can argue it really didn't, because now instead of plus of two different trig functions, I have 1 over multiplication of two trig functions. By the way, an alternative answer for this, what's 1 over sine? What's 1 over sine? Cosecant. What's 1 over cosine? Secant. This is an alternative legal answer to this. And again, you could argue that this is not simpler. This is why today's homework, some work out real simple and you know you got an answer that's good. Others, am I done? All right. And that's going to be a little bit of an issue today. Okay? All right. Hopefully you don't feel too bad about this. This is a very doable chapter, but you just got to get your memorizations down.